So today let's explore what's inside of this Soviet cassette recorder and let's see how does it work and if it's fixable. It's a Vesna 309 and Vesna means spring, the season, not this one, even though it might contain some. Let's take a look at it. It has these buttons: pause, rewind, play, fast forward, recording, and stop and opening. Here you enable the system of hiss reduction, switch two types of tapes and the recording level, low frequencies, high frequencies, and volume. Here's the speaker, some mains power indicator, the record level indicator, and here's the tape and the tape counter with a reset button. And the other side of it, you can put 7 batteries here, C cells it seems. Here's the mains input, and here's the fuse it seems. You turn this and the fuse pops out. Let's check it. You typically always find the wrong fuse or a piece of wire in these old devices. It says 0.16 amps B, and this is also B 160 milliamps. There is the right fuse in it, surprisingly. And the wire seems intact, so let's put it back. Of course, let's use a Soviet screwdriver here, or else. And you turn this and the fuse goes in. And here's some label on it. Tape recorder, Vesna 309, some type number, 220 volts, 50 Hz, 10 volt amps, 7 elements, 343, and the price is 172 rubles. I guess it was bloody expensive back then. 1979, is it the date code? Warning, before removing the cover, you should remove the plug from the mains socket. And yes, it says unplug before opening it. It does not say do not open, no serviceable parts inside, and leave it to professionals, like the modern crap. But I have to say it seems a bit modern for 1979, and when I look into the battery compartment, I probably can see the actual date code, 0388. So this is going to be a silicon thing with maybe some chips. It's not going to be like the 70s Soviet tape recorder I was showing several years ago, which was discrete germanium transistors and no chips. Let's try to plug it in and see what happens. And here are the connectors for the microphone or line input and speaker output. Let's plug it in. Let's see if it works. And for $10 it looks in quite good condition actually, and it unfortunately comes without the original cable, but it's quite a standard plug. I can use this from some 90s CRT television, and let's see, let's put this in, and testing time. This actually lights up, not sure how much it's visible under the studio lights, but there's light. I guess it's a neon lamp. Let's try the play button. It's actually moved. You can hear some hissing and crackling and buzzing. So the audio amplifier is actually running, but the tape is not moving. Nothing. The rubber belts in it might have turned into carbon emissions, crude oil and microplastics. But it's also possible the motor is not getting its voltage. I can't hear anything like a motor in it. Or maybe it's very quiet. And before opening it, I'm just curious. Let's connect an oscilloscope probe to a random coil on a ferrite rod. And let's try to put it next to the eraser head. I'm wondering if this late 80s thing is still a high-frequency AC erase and a bias. Or if it's the crappy permanent magnet for erase and a DC bias for the recording head. Or a universal head basically, because the recording head is also the playback head. Pushing the play button makes the erase head come out, so it can't be a permanent magnet. It would erase your tape when playing it. And of course, to be able to press the record button, I have to press this lever here, the recording protection. A blank cassette has this piece of plastic here, whereas a pre-recorded tape has just a hole here, so you can't accidentally re-record it and erase whatever was on it. I guess if you're watching this video you probably already know it, but there's probably a lot of younger people who don't know it. And of course you can break this plastic piece after recording your blank cassette to protect it. And this bit is what presses the lever, unlocking the record button. And you can also put the tape over the hole to re-enable the recording. And of course the cassette has 2 sides and each side has its own protection. So let's press this thing and this one. Nothing happens. I guess in this one you have to actually press manually both the record and playback, like this. Now the head has actually come out and it's buzzing. Is the input so bloody sensitive or the electrolytic capacitors dried out? And of course for a Soviet recorder, a Soviet oscilloscope, and putting the coil next to the eraser head. And hell yes, it's using high frequency AC to erase the tape. Now it's 2 microseconds per division, and the period is about 1, 2, 3, 4, 5, 5.5 divisions. 2 times 5.5, 11 microseconds. So the erasing and biasing frequency is 90 kHz. Of course, in some rare cases, recorders were using a different frequency for the bias and different for the erasing. Of course, both frequencies not audible, but the biasing one even higher. But in most cases, it's using both the same frequency. In most cases, there is one erase bias oscillator, which goes into both the eraser head with a large amplitude and also into the universal head when used as a recording one. Let's try to change the recording level, no effect, the volume, no effect. But when changing the tape type, it actually changes the amplitude. That's this thing. And if you're screaming, why don't I use a normal oscilloscope? Well, this is a normal oscilloscope for me, but anyway, you can see it's about 90 kHz. And this is still working with all the components original. It's also from 88. Even this thing has all the components in it original, including the capacitors, if you can believe it. But now, of course, let's open it and see what's wrong with the motor. It seems to have 6 screws. And one of them is different, which is always a good sign, isn't it? At least it's still a slotted screw. I guess the later somebody was poking in it in the wars, because each year people are dumber and there is some black residue on them. It was probably sealed, which is no longer. I mean, the seal was already broken before I opened it. And the internals. I was actually surprised. No wires go from this battery compartment, but there are actually contacts making contact with these instead of having wires. That's an interesting design. Here's the speaker, obviously. The battery contacts, the fuse. This looks like a bridge rectifier, quite old school. And here's the transformer. Some board here with some electrolytic capacitors. A heatsink. I guess this is the power supply. Here's the board with the potentiometers. The tone adjustment. Again 88 date code. And the main board here. Here's the motor with the belt. The belt is actually still there. There's quite a lot of wires going from the motor into this circuit. Motor driver on a separate board, and based on the number of wires going to the motor, it has to be an AC motor driven by an inverter. It's not a brushed motor. That's interesting. But I guess it was the case even in the 70s one I was exploring. Of course, that one was too far gone, and I noticed typically the cassette players with these buttons going straight into the tape, the mechanism is less likely to break. There is just less of it to break, whereas the ones with the lever buttons, which are basically flat on a table and you're pressing the buttons from here, there's way more of it to break than in the vertical ones. In the 70s one, there was just way too much of it broken in this mechanism, besides like all the wires in it broken. When you plug in the mains power, it basically disconnects the battery and switches the power supply to mains. An interesting design. And of course there is another fuse inside of it here. And hell yes! There is a wire across it. When you see this, you always ask whether it's worth fixing, and you know it might not be an easy repair. Because then 90% of the effort goes into fixing the mess somebody made, and just 10% into fixing the original problem. And there was also a self-tapping screw forced into this metal insert where the fine threaded screw is supposed to go. Seriously! And here it says the fuse should be 1 amp. What the fuse with the wire is? 0.3 amps. Nice. When it says 1 amp, you're not supposed to put 0.3 amp fuse into it. You're supposed to put a 100 amp fuse into it. I'm just kidding. And you're wondering how all the house fires happen. And there's a blue wire going from it to the transformer. I guess it's AC, it's the secondary fuse. This means the current meter I'm going to connect has to be set to AC. Let's connect it instead of the fuse and measure. Let's plug it in. The play button is already pressed. 0.8 amps. It went slightly down. It's not exceeding 1 amp, so there shouldn't be any problem. And there is no DC current. Of course I could fix the thread here using a tab, but the plastic here is broken anyway. It was probably over-tightened, dropped, and why not both, of course? Let's try to remove this board to see the motor better. And as you can see, this is late 80s. This is mostly chips. Not many discrete transistors here. And the belt actually seems to be still intact. Nice. This one goes to the counter. This one is a flat belt. Here is the switch switching it from playback to recording. The recording button presses it using this. Does the motor turn? Well, it doesn't, or it's seized up. It's extremely hard to move. And here's the motor inverter. 3 power transistors for 3 phases here. Let's take a closer look at the main board here. Most of the electrolytic capacitors seem to be already using the international marking, not the Cyrillic one. 16 volts, 100 microfarads, this should be readable for everyone. A few of them are still using the Cyrillic marking, 6.3 volts here, 47 microfarads, MKF in Cyrillic. And all the resistors seem to be using colors, not numbers here. Transistors already plastic, no metal transistors here. Big flywheels here. This is still nicely built for a consumer product, nothing hi-fi or professional, built in a country not far from falling apart. Here's the pause button, activating this switch. Rewind, playback, fast forward. The record button has to be enabled, pressing this lever. And the stop button. But now instead of playing with it, let's try to fix the motor. I'm probably supposed to remove this entire mechanism. This came out, these 2 screws from here and here. And here it's from the other side. And these go into the cassette. Here's the pinch roller, the universal head, the erase head. Here's the motor. Is it even possible to get to the other bearing of it? It seems to have a lot of magnetic shielding. I guess I can actually open this. Well, it's in some rubber to dampen the vibration, of course. And that's it. This rubber comes off. And here's the motor. Maybe it's going to fall apart and never go back together. I removed these 3 screws, not these 2. These look like it's to advance or retard the timing of something. But of course, let's open it. You're curious what's inside of it, I guess. You know, I would have to remove this from the shaft to fully open it, I guess. Or maybe not. Way too many wires going into it. It looks like a brushless DC motor. There is 9 coils, 3 phases, 3 coils each, I guess. This looks like some position sensor, some coils here, and some rotating magnet here. It's the feedback for the 3-phase inverter. This actually aligns the timing of this feedback, the shaft position sensor. This actually looks more like something you'd find in a hard drive or a floppy or CD drive, more than something you'd expect in a cassette recorder. And the amount of wires going into it is just absolutely crazy. I actually decided to pull this one off and disassemble it for cleaning. There might be some small metal particles that have to be removed. Let's clean the shaft. And the hole. It's probably a horrible way, but... And then let's lubricate it and put it back together. Of course the camera battery is empty and now it's turning nicely. One more look at the motor inverter here. Before I put it back together, some adjustment potentiometer in it. And here is the counter. When you press the reset button, it tilts these gears away from it and the cams on these wheels push it to the 0 position. It surely runs much better without the motor seized, and it also draws just 1/3 of the current from the secondary now. Of course, when the motor can't turn, it draws much more. And testing time. And it's probably working. The volume is super low. This is at maximum. Notice that I need more volume of this. And also, it might be still copyrighted. If you can imagine a person trying to pirate this music. But there is probably something wrong with the amplifier. It seems to be some Slovak music. And the counter seems to work. It's rewinding. Fast forwarding. You can see the minus power neon lamp here. I guess the very low volume is because there is some dried out electrolytic capacitor in the audio path. Some rotten cassette from under the elements. That was a brilliant idea, wasn't it? Of course, let's give it the right fuse. Fast, one arm up. And let's start testing the capacitors. These on the board. I have to unscrew the potentiometers to access them. There are two electrolytic capacitors on this board. This one goes from the slider of the volume potentiometer. It's very commonly the cause of a low volume if it's dried out. 2.4 ohms, which is still quite low ESR for a 1 microcapacitor, so this one is not the problem. And the other one on this board is 0.28 ohms, acceptable for 220 microfarads. I don't think the problem is on this board. This is the volume, high and low tones. And there is also one transistor, and when I have the board removed, and it's not easy to remove, let's check the transistor. Base 2 collector 0.7 volts, base 2 emitter 1.7, or is it PNP? Going from collector to base? No. Emitter to base? No. It looks more like an PN. From base to collector there is the typical silicon voltage drop, but base to emitter, something's not right here. It's marked on the board, but if it's wrong, collector to emitter, no, that's not a junction. Emitter to collector, that's not a junction. Well, I kept poking into the transistor and now it's louder. There's a lot of hiss in it. I ran it with no tape. The hiss is coming from something after the potentiometer, but not the tape. It's not a bad solder joint. The level of the hiss is randomly changing. I really think this could be a failing transistor. DC voltage. Let's measure the voltage drops in operation. Base to emitter, it should be about 0.7 volts in operation. Now it's 1.5 volts. Poking in it. Now it's 0.8. Weird. I've desoldered it. It doesn't have any marking except a blue and a green dot, which surely helps. Let's stick it in a tester. Bipolar NPN, gain 500, quite a lot. But the voltage base to emitter, 1.2 volts, is quite suspicious, it's quite a lot. It should be about 0.6 or 0.7 volts. 979 millivolts. It's different every time. My DIY tester actually tests it as a good transistor, but it's just a simple test with LEDs, it doesn't measure any voltages. But the base to emitter voltage drop is randomly changing. It can be anything from 0.9 volts to 2 point something. I guess it has some intermittent failure. Well, this is a low voltage, low current, low power, low frequency transistor. You can probably replace it with almost any NPN transistor, as long as the gain is roughly in the right ballpark. Both are the same package, even the same pinout, collector base emitter. Let's bodge the new transistor in and let's test it. The new transistor's in now. It's quite loud, and the test with no tape. There's way less hiss. So as you can see, it's not always just the capacitors. Of course, when the potentiometers are out. So this board is back, and let's take a look at the power supply board, which probably also is the final amplifier board. There is really not much of it in it. The final amplifier, this thing, is a chip actually, not a pair of transistors anymore. And this transistor is the power supply, the regulator. The biggest capacitor is 1, and the other quite nice. They're 1000 micro 25 volts. The slightly smaller one is 1000 micro 16 volts. Still acceptable. A tiny one. That was just 1 micro, so 2 ohms is fine. 0.2 ohms for 220 micro good. And 2 100 micro capacitors. One is 6 ohms, that's sort of crappy. And the other one, 70 ohms, gone. 16 volts, 100 microfarads, made in 87. And it seems to be a bit cracked here. And identical electrolytic capacitors typically fail together. The worst one outside of it shows open circuit. How it's even working with these? A new 100 micro 25 volts and a new 100 micro 35 volts. 8 times less ESR. This one is probably a low ESR type. Okay, these will go in it. Let's check the capacitance of the old ones. The one that's 7 ohms ESR still shows about 100 micro. The one that's almost open circuit or completely open circuit shows 90, but this is in nanofarads, not microfarads, so this is completely gone. This is the new capacitors. These are going in it. That's the new capacitors in it. I tilted them away from the heatsink, making it look crappy but last longer. Now the big board. And this coil is hanging on just the wires. I have to glue it back in. Before the wires break, it's glued in now. I guess one of these coils has to be the part of the E-raise bias oscillator. And then of course testing all these electrolytic capacitors in it. All the 1 micro capacitors are about 2 or 3 ohms, nice. The 10 micro capacitors are about 1.5 ohms, still not that bad. 22 micro 1 ohm, let's still leave it there. Another of these 100 micro, which is 10 ohms. And 220 micro, 3 point something ohms, it's already bad. And 47 microfarad is here, completely open circuit. We will be changing 7 capacitors here. 7 capacitors are changed. Here's the board with the new ones. The funny thing is I changed in total 9 capacitors and I can't tell the difference. Maybe if I replaced all of the capacitors using ones made of solid gold, some audiophile would be able to tell the difference. Most of the capacitors were just a high ESR, not completely open, but this one is. And of course one of the 100 micro ones from the power supply and amplifier was. I can also spray the switches here when I have it opened. They're actually open at the back. And of course there are also 4 capacitors in the motor board, electrolytic ones. One of them I already took out. 15 ohms for 47 micro is really bad. The other ones are less than half an ohm. Of course how much the rubber of the pinch roller is deteriorated is another question. The belts can also fall apart any moment, but it works, so I should probably put it back together before it doesn't. And a quick look at the schematics of it. This is the main board. That's the board with the potentiometers and the bad transistor here. The 1 microfarad capacitor actually goes into the potentiometer. Here's the final amplifier with the chip, the rotten 100 micro capacitors, and the discrete transistor voltage regulator. This is the power transistor. Here's a Zener diode, some interconnections, the board layout, the mechanical part of it with the belts, some other interconnections, the switches, and here's the motor driver. 15 bloody wires going into the motor and 12 bloody transistors just to make a tiny motor run. This is quite remarkable. And it's also interesting that when I plug it in mains in the dark, the neon lamp takes multiple seconds to light up. If the ambient light doesn't help it to ignite, it's waiting for some ionizing particle like a Geiger counter. And it's working. Of course I can't really show much of it because it's copyrighted. No, it's not. And of course the video is getting bloody long. This thing seems to be working until the rubber parts fall apart and that's it. But do you like me to show more of these vintage devices, or do you prefer some modern ones, like for example this 40-watt USB charger? And of course if you like my videos, please consider supporting my channel on Patreon using the thanks button and subscribing. Because this is how you keep my channel running, and big thanks to all of you who already support me. And I have a lot of other things to explore. This high frequency generator, digital stopwatch, and this server power supply, several oscilloscopes and some cassette recorders, reel-to-reel recorders,